A battlefield begins as nothing but noise, shouts, thrusters, footsteps, and the crack of kinetic fire tearing through the air. But in the middle of that chaos, there's something else, something that looks like a shimmering cloud clinging to the soldier's body. A fog, silver, alive, swirling with intention. And every time a projectile hits it, the cloud ripples, hardens, and deflects the impact like a microscopic wall of steel. This is the world of Nano-Fog Combat Shields, one of the most extreme, imaginative, and scientifically grounded visions for personal defense technology in the future. It's not a force field. It's not a magical bubble. It's a fluid swarm of nanobots, tiny machines smaller than a dust particle, that reorganize themselves into armor the moment a threat is detected. To understand why this technology is such a game-changer, we need to start with the concept of dynamic matter. Imagine a material that doesn't exist in one state. Instead of being solid or liquid, it's both whenever it wants to be. A cloud that can instantly freeze into a shape, then go back to mist the moment the danger passes. That's the behavior scientists try to simulate with smart materials today, like non-Newtonian fluids or magnetorheological fluids that harden when hit by force. But Nano-Fog takes this idea and launches it into a completely different league. The idea behind Nano-Fog Combat Shields is simple: fill the space around a soldier with a programmable mist. Each droplet of that mist is actually a tiny robot, equipped with sensors, processors, and the ability to form magnetic or molecular bonds with its neighbors. On their own, they're insignificant. But together, they act like an intelligent swarm with one job: protect the person inside at all costs. Picture a soldier walking across a war zone with a faint shimmer around them, like heat haze. That haze is the shield idle mode. The nanofog stays dispersed until a threat is detected, maybe a bullet, a blade, or even a directed energy pulse. And in that fraction of a second, the swarm reconfigures into whatever shape will best stop the incoming attack. If the threat is a bullet, the fog snaps into a flat plate. If it's shrapnel, it becomes a dome. If it's a blade, the fog forms a counter-cutting grid that locks the weapon in place. You're basically watching a living material perform complex geometry at the speed of danger. Now imagine the offensive potential. The fog doesn't only block attacks, but can actively grip weapons, sabotage drones, or even create hardened spikes to puncture enemy gear. As long as the nanobots have enough power and mass, the possibilities are nearly endless. But let's break down the scientific foundations here. What would it take to build a nano-fog shield in the real world? First, we need nanobots capable of autonomous decision-making. Not full AI in each bot, nothing that advanced, but something like distributed intelligence. Think of each nanobot as an ant in a colony. The colony itself is the brain. Each bot senses heat, movement, velocity changes, and electromagnetic data. When enough bots detect something, the swarm reacts collectively. This is similar to how flocks of birds synchronize without a leader, simple local rules leading to complex global behavior. Second, the nanobots need to connect to one another. They might use magnetism, electrostatic bonding, or even microscopic grappling hooks. The bonds need to be strong enough to form a temporary solid but easy to break when the shield dissolves back into fog. One moment they're individuals, the next they become a wall. Third, they need energy. This might be the hardest part. Nanobots would need tiny batteries or a way to harvest ambient energy, like motion, heat, or wireless power beamed from a suit. The fog could also return to charging pods on the soldier's armor when not in use. Picture a belt or chest plate that constantly recharges the swarm, keeping it ready for combat. Fourth, they need a command protocol, some kind of central processor or onboard AI that directs the swarm. This could be built into the soldier's armor or helmet. The AI tracks threats, predicts trajectories, and instructs the fog on how to respond. It's essentially a hyper-advanced, real-time personal defense algorithm. But now let's step into the fun part. How would nano-fog shields reshape combat? First, they would crush the concept of static armor. Traditional armor protects only where it's placed. If a bullet hits your arm and your armor is on your chest, too bad. Nano-fog doesn't work that way. It protects everywhere at once, and it prioritizes the most urgent threats. It adapts its shape, density, and hardness to whatever's coming. No human reflex can match that. Second, nano-fog shields would eliminate the need for heavy exosuits. Imagine getting Iron Man-level defense without carrying 300 pounds of plating. The fog does all the heavy lifting. It distributes impact, counteracts force, and even absorbs kinetic energy that can be reused to power the swarm. Soldiers could move faster, jump higher, and fight longer. Third, the fog could be integrated with camouflage systems. In active mode, the fog is visible when it hardens. But in idle mode, the bots could bend light around the user or display dynamic patterns for stealth. The soldier could switch between protection mode and invisibility mode with a thought. Now let's talk about the offensive side. Nano-fog shield systems might evolve into multi-purpose combat tools. For example, the fog could temporarily create weapons, like forming a spearhead from hardened nanobots or generating a concussive shock plate to push enemies away. A soldier wouldn't carry physical weapons. Instead, the fog generates them as needed. There's also the possibility of aerial utility. The swarm could extend outward like wings or gliders, helping the soldier soften a fall or jump across gaps. It's personal flight assistance without a bulky jetpack. And don't forget enemy disruption. Nano-fog could interfere with electronics, scramble sensors, or clog mechanical joints on enemy robots. The fog becomes both offensive and defensive, an all-in-one battlefield toolkit. But as powerful as nano-fog shields sound, they come with major risks. One of the most terrifying scenarios is a swarm malfunction. If the fog interprets the environment incorrectly, it could lock up at the wrong time or fail to deploy. Worse, if hacked, the swarm could turn against the user or refuse to protect them. That's why encryption and swarm authentication would be crucial. Each nanobot must recognize the soldier as home. Without that, things could get catastrophic fast. Another challenge is environmental contamination. What happens if nanobots get lost, damaged, or dispersed? Could they be inhaled by civilians? Could they replicate uncontrollably? These risks would spark massive ethical debates and likely strict regulations. You're essentially carrying millions of microscopic robots capable of both protection and destruction. Power limitations also mean the fog can't stay active forever. During long battles, the swarm might need to retreat and recharge. Soldiers would have to strategically manage their shield, endurance, choosing when to block, when to dodge, and when to go full fog wall. But despite the dangers, nano-fog shields represent the future direction of warfare. Adaptive, intelligent defense that scales to the situation. And the craziest part? Early versions of this technology are already in progress. Scientists are building microscopic soft robots, liquid metal droplets that change shape, and nanostructures that self-assemble under magnetic fields. It's still far from battlefield ready, but the foundation exists. Now imagine this tech decades or centuries from now. Not just soldiers using it, police forces, emergency responders, astronauts, rescue workers, firefighters. A firefighter could walk through a collapsing building with a fog shield that blocks falling debris. A space engineer could use the fog to deflect micrometeorites during repairs. A diver could use it to create barriers underwater against high-pressure hazards. It becomes universal protection, a smart shield for anyone facing dangerous environments. In everyday life, consumer nanofog might emerge as smart clothing shields. Instead of helmets or pads, athletes wear a thin spray that deploys into armor when they fall. Motorcyclists could survive crashes because the fog hardens around their body at impact. Kids' toys could integrate microshields that prevent injuries. The potential spreads way beyond combat. One of the most fascinating possibilities is the future of swarm behavior. Nanobots could learn. Over time, the fog could become better at predicting threats, customizing protection to each user's movements and habits. Your fog would literally train with you, like having a microscopic personal bodyguard with perfect reflexes. This leads to the idea of fog personality. Different nano-fog models might be tuned for aggressiveness, defense, stealth, or utility. Soldiers could select shield behavior presets before missions. Some fogs might prefer solid plates, others flexible barriers. Some might form close to the skin, others extend outward like tentacles. It adds a whole new dimension to personal gear customization. Finally, imagine the endgame version of Nano-Fog Combat Shields, the kind that science fiction would envy. A soldier stands alone on a futuristic battlefield. Drones swarm the skies. Railgun shots rip through the air. Plasma bolts crackle like lightning. But around the soldier, the fog surges, liquid silver light bending with perfect synchronicity. Every attack is met with a counter. Every threat is neutralized. The fog is not just armor, it's an active, breathing ecosystem of microscopic guardians, evolving with every encounter. This kind of technology would redefine what it means to be protected. It blurs the line between human and machine, turning the battlefield into a duel of intelligence, swarms versus swarms, fog versus fog, AI versus AI. The future soldier becomes more of a conductor than a fighter, guiding their nano-fog with instinct and thought. And when the war is over, when the dust settles, the fog dissolves harmlessly back into a soft glow, waiting for the next threat. A living shield, always there, always ready, always adapting. Nano-Fog Combat Shields show us a future where defense is no longer passive. It's reactive, fluid, personal, even artistic. It's the evolution of armor into something alive. And in the hands of future generations, this technology could be the difference between vulnerability and invincibility. The cloud around the soldier isn't just mist, it's the future of protection. And it's coming faster than we think. Hey everyone! If you enjoyed this video, make sure to hit that like button, drop a comment to share your thoughts, and subscribe so you don't miss any of our future uploads. Your support helps this channel grow. Thank you for watching.